You are probably looking at your class schedule right now, seeing a physics requirement, and wondering how this fits into your degree. If your goal is to design video games, write software, or build interactive digital worlds, sitting in a science lecture might feel like a detour away from the coding lab. Think of the actual physical universe as the ultimate video game engine. Before you can drop a character into Unreal or Unity, the software needs a solid foundation. It needs rules for how fast things fall, how objects collide, and how light scatters across a room. In those programs, you flick a switch to turn on gravity. In the real world, physical laws are those default software settings. This slide defines exactly what we mean by the subject. Physics is the study of natural phenomena, broken down into two main ingredients: matter, the stuff everything is made of, and energy, what makes that stuff move and interact. Mastering these fundamental rules provides you with the exact variables needed to program believable, immersive digital worlds from the ground up. This chart breaks down a major historical split in how we understand the universe. We call this the Great Divide, separating classical physics on the left from modern physics on the right. Looking at the right side of the chart, modern physics deals with the extreme. It covers the behavior of tiny subatomic particles and objects moving close to the speed of light. This is where scientists like Albert Einstein and Max Planck did their work. That understanding of invisible particles allowed us to invent semiconductors, materials that control the flow of electricity. Those semiconductors are the building blocks of microchips, processors, and the massive physical hardware you see here that runs complex computational software. Now, look at the left side of the chart. Classical physics covers the laws of motion and gravitation, mapped out by thinkers like Sir Isaac Newton. These rules govern human-scale objects you can actually see and touch. Modern physics gave us the physical hardware, the consoles and graphics cards we need to play games. Classical physics provides the exact behavioral logic used to build the game's reality. We have all played a game where the physics engine breaks. Characters float into the sky, items fall through solid floors, and cars launch into space when they bump a curb. To fix a broken digital world, you have to apply the correct physical laws. Let's look at this breakdown of classical physics. In the top left, we have mechanics, which is the study of how objects move when forces push or pull them. In coding terms, this is how you program a character's running speed, the arc of their jump, and the hitboxes that detect collisions. Just below that is optics. The slide notes this involves electromagnetic radiation, which is simply the scientific term for how light energy travels through space and bounces off surfaces. Understanding this allows you to design realistic in-game lighting, ray tracing, and accurate reflections on water or metal. On the top right, we find acoustics. This covers how sound is produced and travels through different materials. You use this science to program 3D spatial audio, so a player knows exactly which direction a footstep is coming from, or to create realistic echoes in a virtual cave. But none of those systems work without perfect data. This image highlights tools like vernier calipers and micrometers, which physicists use to measure objects with extreme precision. In your work, taking an accurate measurement is the equivalent of assigning a flawless, exact variable to a line of code. Mastering these specific branches equips you with the exact formulas needed to make a digital environment feel authentic, weighty, and real to the player. This course provides the practical blueprints for your major, translating complex science into the specific tools you will use as a developer. Look at the communication box on this slide. The technology you use every single day runs on the concepts we will cover in this syllabus. Your phone's GPS relies on kinematics, the math of how objects move over time, and vectors, which are arrows that track speed and direction to navigate you home. For your first official module assignment, observe the world around you and identify where these physical laws are powering the technology you rely on. As you can see on this screen, you need to head over to the Canvas forum. Reply to the prompt and provide 3 specific reasons why understanding physics matters to your future creations. Take your time with it. Before you can code the perfect virtual universe, you first have to understand the source code of the real one.